Beautiful mind here. We are continuing our discussion on chapter 2 on exponential and logarithmic functions. Let's do this for now. Here we're going to be looking at section 2.3, derivatives of natural logarithmic functions. A couple of objectives. We like to differentiate functions involving natural logarithms. We like to solve applied problems involving natural logarithmic functions and their derivatives. Given that for any positive number x, the derivative of the natural log is going to be 1 over x, right? So the derivative of the natural log is 1 over x. So in these examples, we're asked to differentiate. So for part A, all right. So this derivative is just going to be basically 5 times 1 over x, or dy by dx is going to be 5 over x. Okay. We have to use the product rule and the sum and difference rule in conjunction with what we just introduced. So then our dy by dx here. So for this first term, we're going to use the product rule. So we're going to say the first times the derivative of the second. So times the derivative of the second. So we're going to say times 1 over x plus the second. First is going to be 3x squared. And then the derivative of that last term is just going to be 4. Go a little bit further. X cubed over x becomes x squared. In that first part, I'm going to write this as 3x squared times the natural log of x. This for the sake of clarity. And then we're going to have plus 4. We could factor out that x squared. Let's go ahead and use the quotient rule for this next part. Or dy by dx is going to be, so the quotient rule goes low d high minus high d low over low, right? So low, or the bottom, times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, right? This 1 over x is going to turn this x squared into just a single x. I'm going, just because I'm running a little bit short on space, we could factor out an x from both of those terms on top, right? So if we factored out an x, they're going to kind of merge and just kind of skip some steps, but those x's are going to turn this 4 into a 3, right? Okay, now if I account for those changes, let's see, it looks like kind of out of space. We're going to have 1 log of x over x cubed. X, you see it there. X squared plus 3x squared natural log of x plus 4. 3x squared natural log of x plus 4. And then we got 1 minus 2 natural log of x over x cubed. 1 minus 2 natural log of x over x cubed. Okay. All right. Just on the side, I got like a Dragon Ball Z Dokkan battle going, and so they've done this latest update called version Z. So I really like it because they've added this like auto farm feature where you can like have it automatically run through the stages for you. So that was why I paused for that split second to just go ahead and start another run, let it auto farm. It's really nice. It frees up my attention, not to be so distracted again. Like I'm convinced we're inundated by distractions. Like, why are we so distracted? What is it that they don't want us to see? What is it that they don't want us to focus on, right? They'd rather us be distracted by like entertainment and worry and fear and all this other stuff. But once you abandon your fear and you remove your distractions, what happens? Then you start to become a love-based being, you know. Anyway, don't get me started because I listen to a lot of Ralph Smart and the stuff he says makes a lot of sense. Anyway, let's focus, get back on task. So we have this theorem 8. Now, so we've introduced the derivative of the natural log is going to be 1 over x, right? So now what if we have the derivative of natural log of some function, right? So it's still 1 over that function, but now we say times that function, times f prime, right? Or in other words, the derivative of natural log of some function is going to be f prime over f, right? So way of looking at it, for u times times basically like a u prime or a du by dx. In other words, the derivative of the natural log of a function is the derivative of the function, yeah, f prime over f, right? Okay. Well, we're asked to differentiate, so let's start with part A. Okay. We have y equals the natural log of 3x, right? So then x f prime over f, right? So the derivative of 3x is 3 over 3x. This one just happens to simplify down to 1 over x. Let's see. So we have y equals the natural log of x squared minus 5, right? Then our dy by dx is going to be f prime over f. So f prime in this case is going to be what, just 2x? And our f is this x squared minus 5. Then they cancel there, right? Okay, we're going to go with that. Paste. We have f of x equals the natural log of the natural log of x, okay? So then f prime is f prime over f. So the derivative of natural log is going to be 1 by x over the natural log of x. And we can kind of rewrite that as x natural log of x. 1. If our f of x, let's see, now on top we have this x cubed plus 4. On bottom we have x. We're taking the natural log of all of that. Okay. So then our f prime is, so we got to do the derivative of that quotient. We could rewrite it. Let me think. I think I'm gonna just use the quotient rule. So that's gonna be the bottom times the derivative of the top, which is gonna be what, 3x squared minus the top is 1 over the bottom squared, and then all over the original. I'm gonna run out of space here. Natural log of x cubed plus 4 over x. Okay. Let's see. We could distribute the negative. We'll go to x cubed. Okay, we need to try to simplify this. So we get 3x cubed minus x cubed is going to leave us with, so it's going to be 2x cubed minus 4. We could factor out a 2 with anything. And then on bottom, the x squared is going to go in front of this natural log of the original. Whoops, right here. Let's see, how do we do? So for part A, we got 1 over x, we got 2x over x squared minus 5, 1 over x, 2 over x squared minus 5. Then we got 1 over x natural log of x, 1 over x natural log of x. And then the final one, 2 minus 4 over x squared times the natural log of the original. Minus 4 over, oh, I see what they did. Let me go back. The quotient becomes the difference of the logs. Okay, I'm gonna, so we need to go a little further. So some more space. So I guess we could have, yeah, so separated that log, right? We have the log of a quotient. Let's go ahead and do it. I am going to scrap this and just give myself some more space. That's part of it. I was trying to jam it all in. Let's get rid of this. Yeah, that's awesome. Can I just paste now? No. Let's redo part D with that added information. So then for part D, again, our f of x, x cubed plus 4 over x, and we're taking the natural log of this. Okay, so this original part, we have the log of the quotient. We can apply the properties of logs. This is going to be the same as the log of x cubed plus 4 minus the natural log of x. All right, so you can break it apart. Then let's differentiate. That'll be a lot easier to break down than using the quotient rule, right? So then f prime, so that first part is the derivative of a log is du over u, or f prime over f. So then that's going to be 3x squared over x cubed plus 4. It's 1 over x. We could get a common denominator and combine those. Let's see how did they finish for part D. Let's go ahead and just do that really quickly. So if we were going to combine these, multiply by 1 in the form, to get a common denominator, we multiply by 1 in the form of x over x. The second one we multiply by 1 in the form of x cubed plus 4 over x cubed plus 4, all right? So then if we do this, we're gonna have 3x cubed. Let's distribute that negative. It's gonna be minus x cubed minus 4 over x times x cubed plus 4 for now. So then x cubed minus 4 over x cubed plus 4. Okay. This is where they stop. Let's just kind of go back and forth. I lost one. Okay, that's okay. Let's see how to do finish. There it is. Yeah, 2x cubed minus 4 over this side. Okay. Okay, that's okay. Let's keep moving. So the quick check, as of late, I've been leaving that as an exercise for you all. And then we have this example. So we have this example 3 says that in a psychological experiment, students were shown a set of nonsense syllables such as POK, RZ, DEQ, and so on, and asked to recall them every minute thereafter. The percentage RT who retained the syllables after T minutes was found to be given by this the logarithmic learning model that you see here, where T is between 1 to 15. I'm assuming that's minutes. Right? Yeah, 1 to 15 minutes. What percentage of the students retain the syllables after 1 minute? And then find R prime of 2 and explain what it represents. So retain the syllables after 1 minute. So when T is 1, natural log of 1 is 0, right? 80%. So after 1 minute, the result we get there was 80. Right? I just plugged in 1, natural log of 1 is 0. So then this term goes to 0. So all the stuff is at 80. And then find R prime of 2. Now let's go ahead. So then again, for part A, we found R1 was 80 minus 27 at the log of 1. And we said that basically all of this collapses to 0. And we were left with 80%. B, so if R of T is 80 minus 27 has a natural log of T, 1 over T, so that becomes a negative 27 over T. All right, because the first term, the derivative of a constant is 0, is this. So then they ask us to find 2. So then that's going to be a negative 27 by 2. Is that 13.5? Negative. After 2 minutes, they remember 13.5% less information. Okay, I think that's what that means. Let's see. Let's paste. A, we got 80%. You see it here. E, negative 13.5. So this result indicates that 2 minutes after the students have been shown the syllables, the percent of them who remember the syllables is shrinking at a rate of, okay, so I think I did kind of miss a little bit of, remember 13.5% less information. This is really, remember the syllables is 13.5% less. It's shrinking at a rate of 13.5% per minute. Okay, that's fine. All right. And then as a quick summary, so the derivative of the natural log is just 1 over x for all positive x. And then for functions of the form, we have the natural log of x of some function. Then we use the chain rule. right? So then it's basically f prime over f. Okay, all right. All right, and on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care, guys. Peace.